Hi everyone, this is lesson 4 in statistics. So far we learned about measures of central tendency, mean, median, and mode, and measures of dispersion like range and standard deviation. Now we're going to look at measures of position. So how does any given data point compare with the mean and the standard deviation? To do so, we're going to learn about the z-score. We're going to compute and interpret percentiles, compute and interpret other types such as deciles and quartiles, and work with box plots. In some cases, we're interested in certain individual items in a data set rather than in the set as a whole. We need a way of measuring how an item fits into the collection, how it compares to other items in the collection, or even how it compares to another item in another collection. There are several common ways of creating such measures, and they're usually called measures of position. If X is a data item in a sample with mean X bar and a standard deviation S, then the z-score of X is given by Z equals the value minus the mean divided by the standard deviation. Two students who take different history classes had exams on the same day. Jen's score was 83 while Joy's score was 78. Which student did relatively better given the class data shown below? So Jen had a class mean of 78, whereas Joy had a class mean of 70. So that's X bar. And then the standard deviation is 4 compared with 5. So let's calculate each's z-score. So the z-score of Jen would be X, so Jen's score was 83, minus the class average of 78 divided by 4. So that will be 5 divided by 4, which is 1.25. So Jen's z-score is 1.25, whereas Joy's z-score, well, how did Joy do on the test? She got a 78, so it appears she did worse, but the class mean was a 70, and dividing that by a standard deviation of 5. So that's 8 divided by 5, and 8 divided by 5 is a z-score of 1.6. So Joy actually had a higher z-score, meaning that compared with the rest of her class, she did comparatively better than Jen did within her own class. So imagining that Joy might have been given a harder test and might in fact know the material better compared to Jen, who might have been given an easier test but scored relatively lower compared with other members of her class. This is assuming that both classes are of similar ability. Percentiles. When you take a standardized test taken by a larger number of students, your raw score is usually converted to a percentile score, which is defined on the next slide. If approximately n% of the items in a distribution are less than the number x, then x is the nth percentile of the distribution. It's the nth percentile of the distribution, denoted P sub n. The following are test scores out of 100 for a particular math class. So we want to find the 40th percentile. Okay, first thing I'm going to do is count how many numbers there are. So there's 1, 2, 3, 4, 8, 12, 16, 20, 24, 27, and 30. So there's 30 numbers altogether. And we're looking for the 40th percentile, so we want 40% of 30. So that'll be 0.40 multiplied by 30. So 0.4 times 30 is 12. So that means that we want the 12th number. Okay, so finding the 12th number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 12th number is a 74. So that means any of the numbers below 70. And so the 40th percentile is actually one more number, so it's actually 75. So the 40th percentile is 75. That means lower than the 40th percentile would be 74 and lower, and numbers above 75 would be above the 40th percentile. Deciles are the 9 values denoted D1, D2 through D9 along the scale that divides a data set into 10 equal parts. And quartiles are the 3 values Q1, Q2, Q3 that divide the data into 4 equal parts. Okay, having the same data set as before, we want to find the 6th decile. Well, the 6th decile is the 60th percentile, so we could multiply 0.60 times the 30 numbers in the data set, which is 18. So that means that we will want the 19th item. So 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19th. So that means 82 would be the 6th decile. In terms of quartiles, the second quartile is the median, because if you think of a list of data, you could break that into fourths. So here's Q2, here's Q1, and Q3. So the middle number is the median, that's Q2. And then taking that half of data and dividing it in half, you'll get the first quartile. Similarly, the third quartile. Okay, so given these 30 data numbers, we're looking for the 3 quartiles. So Q2 will be the median. Well, there's 30 numbers, so that'll happen between the 15th and the 16th number. So 1, 2, 3, 4, 5, 6, 7, 8, 16. So right in between these two numbers is Q2. So that's at 78.5. That's the average of 78 and 79. So adding them and dividing by 2, Q2 is 78.5. That means Q1, we're going to divide the list to the left in half. So we have 15 numbers there. And then we're looking for 15 divided by 2 is 7.5. So we're looking for the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. So that's 72. Whereas Q3, we're going to look for 8 more numbers. 1, 2, 3, 4, 5, 6, 7, 8. So that's 88. Those are our quartiles. A box plot or box and whisker plot involves the median, the measure of central tendency, the range, the measure of dispersion, and the first and the third quartiles or measures of position, all incorporated into a simple visual display. For a given set of data, a box plot consists of a rectangular box positioned above the numerical scale extending from Q1 to Q3 with the value of Q2, the median, indicated within the box, and with the whiskers or line segments extending to the left and right from the box out to the minimum and the maximum data items. Okay, so we want to construct a box plot for the weekly study times shown below. Okay, so step one, let's figure out how many numbers there are. There's 2, 4, 6, 7, 8, 9, 10, 11. So 20, so it's out of 20. So that means that the median is going to be between the 10th and the 11th. So it's right in here. So Q2 is going to be at 6.5. So Q1, now we're going to divide those 10 numbers in half, and that'll be between the 5th and the 6th number. So that's 8.5. And Q3 will be between the next 5 and 6 numbers. So 1, 2, 3, 4, 5. So between 7 and 9, which is at 8. Looking at this, I realize that I'm missing my stems. So Q1 is actually at 28.5. Q2 is actually at 36.5. And Q3 is actually at 48. Okay, so now I can plot in my box and whisker plot, which goes from 15 to 66. So if this is 15, then I can go up by 5s. So here going by 5s, we're going from 15 to 70. So the smallest value is at 15. The largest value is at 66. Right about here. Then Q1 is at 28.5. So right halfway here. Q2 is at 36.5. And Q3 is at 48. So drawing in my box and whisker plot, here's the whiskers. And here's the box. Right there. So that's at 36.5, 48, 66, 15, and 28.5. There's my box and whisker plot.